Hello and welcome back. Now it took me quite a while to run all these trials, but now we are finished here. And let me actually go to the code section here and let's take a look at it, right? So let's say the best model in total, so best model considering all the trials, is equal to tuner.get underscore best underscore models. Here we go. And because we got several models, it's a function here, we simply need to define, in this case, the 0, so the first element here. So that's the best model. We can run this just to save it in the best model here. Okay, that's fine. And now if I go in here and simply say for this best model dot in this case evaluate just to make sure that what this best model gets our or what kind of accuracy it gets on the test data here. Say test images, and then refer to test labels like that, labels like that. Okay, and let's actually run this and let's take a look at the output here. And we can see that we get, in my case here, an accuracy of 81%. And this accuracy is definitely better than all the other accuracies we had so far, right? So after tuning our network using this hyperparameter tuning from the Keras tuner, we get a higher accuracy and the best kind of model we had so far. So basically training this and using the tuner definitely worked to improve our model. Okay, so good, so far so good. And now what I like to do is I like to take a look at the model itself. So you can do that simply by call best model dot summary. So there's a summary function, summary like that, just in case you want to see what this best model structure looks like. And you can see it here, average pooling to D, then it has a convolutional layer here, a max pooling layer, dropout, a flatten, and then a dense with, in this case, for instance, 1024 here neurons. Okay, that for instance would be configuration here for that. And also here, for instance, from the convolutional layer, you can see here 32, right? Okay, and there are all above 75 million parameters, so a lot of weights which the network needs to train here, or has trained for us, but this helps us to get this 81% accuracy. Okay, so what else can we do? Well, we could take a look at the tuner.summary or result summary. It's called result summary here, and you can run this here just to get a few more additional information about all the trials you had, like the hyperparameters, as you can see here, and then a trial summary, get different kind of trials here, and so on. You can scroll down if you want to do that. Of course, there's a lot of trials, so that's just an option to visualize that in case you want to have more information. So in this case, I don't need that, so press the hash symbol just to comment that out. Okay, all right. So, and what else can we do? Well, one thing, of course, is we can save our model as well as loading the model. For instance, I could say, if you want to save it, you can say best models here, best model dot save in this case, and then you can simply say, okay, my model is, for instance, in this case, my model, or the model, or let's call it model. Let's call this model dot h5 as h5 storage type here, and you can simply run this here. And if you do that like that and run this, of course you can go to the codes here, and if you type in an exclamation mark and then ls, so that simply gives you an overview of what's in the current directory here in Colab, and you can see here we have saved, in this case, this model h5, right, in this case. Okay, so what else? Of course, I could now load this model, so if you now want to use this model again, you can also say the load model, or loaded model from your loaded model, or a new model, if you want, is equal to, and I can say, in this case, keras.models, models.load, just in what you load this back again, and then you can simply say, of course, then you need to have the same name, model.h5, this would be the loaded model. You can run this again, and then you have, just a second, model, Keras model has already been load, of course, it's called load model, sorry for that, so load model, okay, model. Here we go. You can run this here, and then you'll see that basically you've saved now here. I'll get a little warning area here, but that's not an issue here actually. Here I saved my model in this loaded model, and of course I can either use the best model, or I can also use this loaded model just to make a prediction. For instance, you can see that if I say loaded model here, loaded model dot evaluate as an option, evaluate, and I can also use here the test images as well as the test labels. Test labels like that, and if you run this, you should get the same. We should get the same output here. As you can see here, we get the accuracy as well as the loss here, exactly the same values as above. Should be exactly the same values here, right? Because you can now use the load model as well. So saving a loading model it's actually pretty easy to do. Simply call this model.save and save it in a specific format here, for instance, and you can use load model to get the model back. But please be aware that this model we have used here and trained here is probably really big. I think it's I checked it, and it's above 800 megabytes, I think. So if you want to download it from Google Colab, you might run into issues, and also it might take quite some time to download that. Just wanted to mention that here. That is one issue here if you use Colab. So that would be better if you have a personal computer. You're on your personal computer, then probably it's much easier to save the model to your local drive. You can still do it. You can try that in Colab, but here really, because the model is pretty big, that probably you might run into issues here. At least I did. So that's why I don't want to show it to you here, because it really didn't work for me. But what else can we do? Now we can use this model here. At first, of course, we can take a look at the images. Let's say we want to plot one of the images. Let's say RGB, because RGB image at the beginning, it's an RGB image. Image is equal to, and I simply say np.array. So again, we are using the array function, convert an array from a list convention. Say example, in this case image, and now .numpy. Of course, we want to convert the tensor first into a NumPy array, and now say for example in, and now say in ds_train or train dataset, and now say take and 1. Simply, this take 1 simply means that we only take one specific element from the training dataset, one example, so one image, and we convert this into a NumPy array, this tensor, and then we had a list because we have a list comprehension here, and we convert it then into a NumPy array and save it in the RGB image. Okay. And then we simply say RGB image, and we want to have here the first element, so it's equal to RGB image, and then 0 for the first element. And then we simply say, in this case, we can show this, so plt.imshow, because we want to show an image, and we simply use this RGB, so RGB image, okay, RGB image, like that. And we can also plot the shape. Let's say RGB image dot shape, like that. And let's actually run this, and we can see here we got the shape, and we also got here the image as well. And you can see here we got obviously a scissor here. Okay, so this is a scissor. Now let's figure out what the model actually thinks that is, right? So we can do the same. We can simply say, okay, our model result is equal to, and I will say, in this case, either the loaded model or the best model. Doesn't matter which one you use because they're basically the same. So that's a best model dot predict in this case, and then say np.array in this case. And again, we're referring to the train images, and then 0 here, like that. Okay, 0 should be, I think they're missing just one, maybe I'm missing a parenthesis here. Yeah, np array. There should be also one parenthesis here, as well as then another one here, right? Like that. Okay. So we predict this array here, and let's figure out what the result is. So let's say print result, like that at first, and let's run this. Let's take a look at the output, and because we got 3 different classes, remember, we got basically here this, for the softmax function, these are the probabilities, and we can see our model clearly thinks that it's class number 3 with 99%. So let's actually figure out what this is, right? So in this case, what is it? Well, it's rock, paper, scissors, actually, so it makes sense that this are the rocks. This is probably of a paper, and this probably of a scissor, right? Of course, you can also label this if you want, but basically that's the case, and so obviously the model is totally correct here, and when figuring out or thinking that this is a scissor here with 99% accuracy, okay? So that's already pretty good here. Of course, you can also then, if you want to have it like that, you can say the predicted value is equal to np.argmax. If you know this function, you can use this as well from the results here, and then you can say I want to predict the print results, and print, you want to print then the predicted value, right? Value like that. You can also do that, and if you run this here, you'll see that you get 2 here because it starts with 0 indexing, so 0, 1, 2. So obviously, this case the third class again, it's here simply the scissor class. So of course you can map this, right? You can say, for instance, using the map function or any other kind of function, and map this number to a label. So you get a scissor if you want to do that. Okay, so that would also work. Now, that is that, basically, and that's actually all for it for now, for this model and the training, as well as the tuning of the hyperparameters. So hopefully that was interesting to you, and as always, thanks a lot for watching, and I can't wait to see you in the next video. Until then, best guys.